Okay, demo. I think so. Accelerometer. What can you do with accelerometer? This was the very first prototype before. I mean, this was made using existing evaluation board before we laid our own board. So you can see it's when you shake, there's acceleration, right? So it's plotting acceleration in 3 axes in real time. So as soon as it measures acceleration, it throws it to the receiver board that's connected to the computer, and it displays it. Okay, so well, that's what an accelerometer does. But what are its applications? Well, let's take a look. Okay, there. This was that's an equal node put on the baby's forehead and wrist and ankle, and then there's the base station on top of the incubator. And so the baby is moving, jerking. Oh, I'm cold, or something. Well, whatever it is, it's measuring the baby's activity. And some babies are hyperactive, others are just not moving very much. But you know what's interesting about this is if you can if they're making random limb movements, they're okay. But if they are jerking together, synchronous, so both arms and legs, they have sudden movements together, that actually is an indicator for some nervous or brain disorder. Okay, so and it's linked to what's called cerebral palsy. So yeah, so that actually has been used in real studies, and so these things can be quite useful. Okay, now let's see what other applications there are. Well, you can use it as a tilt sensor. So you tilt the accelerometer, and it rotates the cube accordingly. So how does that work? Well, we're on Earth, right? And so on Earth, you have gravity of 1g, right? And so that means on Earth, it's like you're accelerating downwards, or you're experiencing the same force as accelerating downwards at 1g, right? So even if you're not moving, an accelerometer can measure 1g acceleration or minus 1g acceleration down, okay? And so by tracking the gravity direction, then you can use it as a tilt sensor, okay? So that's a simple principle that turns out to be quite useful. And so then what else can you do with it? You could hook it up to a remote control car and use it like a joystick, right? So you tilt it moves forward, tilt it the other way, it moves back, turn the wheel, and so forth. Okay, and so it's a wireless joystick that you can put on the finger. So you put 10 on each finger, you can control 10 cars at the same time. Okay, and then this is another thing you can do with it. It's not relying on the gravity, but it's just acceleration of your finger. So you can interpret the acceleration and map them to keys on the keyboard. So these are mapped to like your keyboard left, right, top, down, right, or sometimes control keys. So and then you can do any arbitrary assignments because you can interpret it however you want, right? So just map it to a key code. You decide when to start, when to stop, and you decide the boundary. So then you can play a little game for fun. So yeah, I guess that's a new way to make a new game out of an existing one. Yeah, so some of you may have played with this one. Okay, so new way to play it, no game. So, and then you get a good workout out of it. doing this all the time. Yeah. Maybe you at the end you get a sore arm, but at least you get some workout. Yeah. So.
好，然后就是缩小关掉。
Okay. Okay. So this is what our grad students do for fun in the lab when I'm not around.
OK，可以停了。
Okay, and you notice there's a base station, right? Because this was before the Bluetooth 4.0. So you need a separate receiver to then translate what it receives to the computer. And this was actually over Ethernet. Now, if you have Bluetooth 4.0, you don't need that separate box. It works directly with the computer. So, but anyway, the principle is the same. It's using acceleration as a gesture input device. Okay. Now we built other things in our lab too, like even a bigger remote car, IP camera. No, that wasn't my idea. The students wanted to do that. There's light switches, relays, IP gateways, and all that. Now here is, I guess I don't have that to show, but we have a smart home control. Oh, this one is interesting. So you notice it's tracking. It's what's called translation and rotation. Okay, let me pause for a second. Okay. Okay, let me pause for a second because now back to the way accelerometers work is that it can sense acceleration in 3 axes, but a solid object in a 3-dimensional space actually has what's called 6 degrees of freedom. Why? Because you have translation, that's linear motion in 3 axes, x, y, z. And also you can do rotation about x and y and z, right? So together they are all independent. So that means you can be moving in x and y and z while rotating about x and y and z at the same time. But if you have only a triaxial or 3-axis accelerometer, you can not distinguish between translation and rotation. That means you need at least 2 triaxial accelerometers to be able to distinguish between translation and rotation. Okay, and if you want to know detail, I can give you papers to read on this. But anyway, so this one, if you look, there are 2 equal nodes on the opposite corners of that cube. Okay, one on top, one on the bottom. They're on opposite corners, and so that's how you can track both acceleration, linear motion, and rotation at the same time. You need a pair. So otherwise, earlier when you see the cube rotation, it wasn't doing linear motion. It was only rotating at the same place. Okay, so that's what's called inertial measurement unit, or IMU. Now, okay. Now this one is interesting. This is a data grabber. So it's using the tilt as a mouse, but you have 2 modes. You're holding down the mouse, that button, and it's tracking your XY direction. You release it, it's back to gesture recognition. Okay, so you see he's holding and releasing, holding and releasing. If you want to move the mouse, you hold the button, and you can tilt to move. And if you want to do action, you release the mouse and move your finger. Okay. So now, he was not only using it as a mouse, he grabbed the file while it's selected. And this is a second computer, not second screen. He jumps over to the second computer wirelessly. And then now he's controlling the second computer. And he took the file he just grabbed, transferred it over here, and says success. And Okay, you know what's going on here? So it's a very powerful mouse, and he's playing the video we just saw. So yeah, so see, he's now controlling this second computer. Selects another file, and then one gesture says grab, and then change. Now he switches back to the first computer now. So connection is broken from the second, connects back to the first one, and then he finds the folder, and then says put. Okay, transfers the files over, and then now he can open that file. So you don't have to take a USB stick, put it in, find the file, copy it, pull it out, put another USB, and then copy it out. It's one. Pretty cool, huh? I think. Okay, so this is a demo. No, we actually have an FTP server, so that means it just grabs the file path. Yeah, it doesn't grab the data itself. It grabs the URL, and you have to be running the server. Of course, in real life, you probably want more security, more protection, because otherwise anybody could grab any file you want. But yeah, because it grabs the URL or a file path, so it could be as large as you want. Yeah, but yes, it'd be nice if it actually sucks up the data into a little device, and then gives it to another one. We're not there yet, but maybe you want to do it as a project.